Testing. All right. Can you all hear me? Sweet. Okay. Welcome to my session. Thank you all for coming. My name is Kaya Imani, and today my mission in life, at least over the next hour, is to help you understand why role-based access is so yesterday. Now, I'm a storyteller, so be prepared for a number of different stories during this next hour. It'll help me convey the information in a way that's hopefully a lot easier for you to understand than just spitting facts. Okay, so let's set the scene. Imagine, like a lot of us, you've just checked into the Radisson Blu. You pick up your key card at the front desk and you swipe it at your door. And you settle in, but soon you realize something that's a little bit unsettling. Your key card doesn't just open your room, but it opens everyone's room in the hotel. Now imagine that every other guest in this hotel, you look to your left, look to your right, everybody here has the same kind of key card. And suddenly anyone that's a guest at this hotel can open any room. Your room, the penthouse suite, the honeymoon suite, if there is one, any room. Privacy, security, gone. Now, this is exactly how role-based access control, or RBAC, works when it's applied to applications. Because when you checked in at the front desk, you were assigned a guest role. And the guest role grants access to all guest rooms. Make sense? Why? Because that's what roles do. They group people into broad buckets and assign access control based on that. Roles just aren't precise enough for cases where guest X only can access room 856. In a real world application, just like in a hotel, access needs to be tailored to a specific context. Now, you wouldn't trust a hotel in which you had access to every room, right? Just like you wouldn't trust an application where your users had access to every part of your application. So, what do we use instead? Short answer, complex authorization cases need flexible solutions, and relationship-based access control using a tool called OpenFGA, which is an open source tool, would solve this case with ease. Okay, before we get too far, let me introduce myself. Again, my name is Kaya Imani. Before you ask, no, that is not a typo. I am indeed a full snack .NET developer. Not sure if that joke landed. I am currently a free agent developer advocate seeking my next opportunity. I am an 8-year Navy veteran for the US Navy, Hoo-ya Go Navy, and I moonlight as a founder. And I am a security enthusiast. So, let's talk about what we are going to go over today. We'll first level set with a brief explanation of auth-in versus auth-z. We'll go over a few popular access control models and talk about the pros and cons of each. And then we'll talk about OpenFGA and where it fits into the authorization picture. We'll also have a look at some high-level examples of OpenFGA implemented and an example of authorization modeling. Then, if we have time, we'll open up for questions. If we do run out of time, then I will make myself available right outside in the hallway track just after this talk. How does that sound? Sweet. Let's get this show on the road. Okay, I told you there's gonna be stories. So, here's the next one. When you go into your friend's house, right? You ring the bell and they see you, they identify you, and if they recognize you, they invite you in. Depending on the level of trust you have with your friend, you may have access to certain rooms in their house and not others. So, for instance, if your friend invites you over for dinner, chances are you're gonna have access to the dining room. You'll probably have access to the bathroom, but depending on the kind of friend you are, you might not have access to the bedroom. Depending on the cook in the house, you probably won't have access to the kitchen. And you probably shouldn't go wandering around their kids' bedrooms. This doesn't make sense, right? It would be impolite and it would probably get you kicked out if you start exploring other places in their home that you don't have access to. Now, off-Z in this scenario is your friend telling you which spaces in their home that you have access to, and off-in the scenario is your friend seeing you and recognizing you and inviting you in. Now, for the scope of this presentation, we are going to focus specifically on auth-Z, or authorization. Next. Okay, so before we get started with Access Control 101, I'm going to introduce you to a legend of sort that we're going to use to follow our examples in the next few slides. We'll start off with entities. Entities, pretty simple. Things that want access to stuff. In the next couple of examples, our entities are going to be our users, which is why we have our little user icon here. Next, we have rules, and rules are the things that grant or deny access of entities to resources. And resources, finally, are the things that entities want access to. Now, access control regulates who can view, use, or access resources. So authorization and access control are kind of interchangeable terms. Okay, so this is the access control model that's probably most familiar to everyone. Role-based access control, or RBAC for short, is an access control model that's based on having roles, right? Roles are like hats. You can have one hat, or you can wear many hats. Which hat are you wearing today? Right now, I'm wearing a speaker hat, and you all are wearing the audience hat, and I am grateful for that. Next slide. Okay, so different roles have different names, and each of them have access control assigned to them. You can wear many hats, as I mentioned, or you can have many roles. In this example, we have admin, manager, and employee. Now, our entity is an employee of ours. We have the blue employee hat. According to the access control rules, an entity needs to be either a manager role or an employee role to access the resource. So, because our entity is an employee, they can access the resource. They pass the checks. Let's have a look at what this looks like in code. Here, we've got a code snippet from a simple document sharing app where we've added in authorization using RBAC. Notice that we're checking for the user's roles and whether there are an employee or a manager. And if the entity passes this check, they'll be granted access to the document. If the entity fails the check, then they're thrown a 403 forbidden error. and denied access. This approach works pretty well for very simple use cases. But what happens when you have more roles like developer, designer, product manager, like we have in most of our applications, right? Well, depending on the level of access you want to grant, you're going to have to perform a check for each of these roles. And that check is going to grow and grow until you eventually run into scalability issues. Another possibility to help mitigate that is to address this problem using RBAC with permissions. So instead of specifying a role, you're specifying the permissions in the access token. So in this case, instead of specifying roles, the rules say that the user must have the document read permission to access the resource. Now, our user or entity in this case is still in the role of an employee, but they have a few additional permissions: document read and document write, so they can access the resource. Now, let's have a look at what this looks like in code. Here, we only have one check, and it checks for if the user has a document view or document read permission. Then they can access the resource. Otherwise, they'll get a 403 forbidden. Now, this works. It makes things a lot easier, but what happens when you only want to share access to a single document? Or let's say you want to revoke a permission. How can you do that? Well, since the permission is already encoded into the access token, you'll have to wait for that to expire, which isn't the best use case. In general, RBAC is good for things like granted broad access to resources that won't change much. But examples of this can include all managers that can approve all expense reports, or all engineers can have access to all servers, et cetera, but that's not generally the case in most of our systems, right? In general, thinking about logically, managers have access to approve expense reports to their team, and engineers, there should be a little bit of a narrower scope about which servers they can access. All right, next, let's talk about attribute-based access control, or ABAC for short. ABAC is similar to RBAC, except for the fact that it is based on attributes. In this case, the attributes that we are looking at are security clearance, time, and IP address. But attributes can be anything. They can be temperature. They can, well, we've got IP address, so location. They can be a number of things. The list is endless. In this case, the rules are saying that in order to have access, you must have a security clearance, and it can only be accessed between the hours of 9 a.m. and 5 p.m. But look at the attributes that our user has. They do have a security clearance, which is great, but look at the time. It's 6:30, so they cannot access the resource, unfortunately. Now, attribute-based access control is great. But think about this. When you have resources that are nested, you run into issues. In this example, we want to read a document in a folder that may be a parent of another folder. If we want to do that, we'd have to recursively go up the chain to identify all the folders that our user may have access to. Also, let's say our user is a part of a group that is owned by another group. Similarly, we have to go recursively all the way up the chain to see all the groups that the users belong to, which is a big pain. And it can cause latency due to the sheer amount of computing power that it takes to perform these checks. Now, you also have to hit your database over and over again to make sure to perform these checks, which increases the load on your database. And lastly, you'll have to perform these checks for each entity resource combo, which is going to be taxing from a resource perspective. And by resource perspective, I mean your actual database. Now, that brings us to relationship-based access control, or RBAC for short. RBAC is a very different way of looking at access control. Let's go back to our example to make it easier to understand. First, let's start off with our entity. Since we're talking about relationships here, we're going to make her a little bit more relatable and give her a name. Her name is Alice. Alice is a level 1 application support specialist at a large tech firm. Alice is a member of the application support team, and the application support team has recently been reorged from being a part of the customer success department to the IT department. And the IT department owns the documents that Alice wants access to. I think you can see where this is going. By modeling this relationship, we can infer based on the relationship existing who has access. So let's take a look at what this looks like. Instead of looking at Alice and what Alice has access to, we can manage access based on the rules of the new entity, which is the document. Now, earlier I said that that resources can be entities, and this is what I was referring to. In this particular case, the document becomes the entity. So we don't really care about the roles that Alice possesses or the permissions or attributes that she has either. When we look at the document, we can tell what can be done with it. And in this case, the actions are can read, can write, and then we also have some relationships defined. So we've got owner, we've got parent, and we've got viewer. Okay, so who can read the document? Well, the viewer, the owner, and the viewer from parent. And viewer from parent in this case would mean that the parent would likely be a folder, and the folder might have assigned viewers. So if you can view the folder, you can generally view the document. Now, how about who can write? The owner or the owner from parent. In our case, the most important definition is the viewer. By this definition, if the entity is a member of the group that has access to this document, then it is inferred that they can access the document. So, based on the relationship depicted, Alice can access the document. Okay, so let's say that the company does another reorg, and instead of being in the IT department, application support goes back to customer success. Well, what happens then? Well, if the relationship ends or the relationship breaks, access is revoked. You don't have to wait for any tokens to expire. You really don't have to manually do anything down the chain. All you have to do is manually break that relationship. All right. Okay, so let's introduce the star of the show here, I know this is the moment you all been waiting for. OpenFGA is an open source authorization platform made for developers. OpenFGA allows us to define precise permissions for any scenario, from basic roles to advanced conditional access. Now, I know the premise of this presentation is anti-roles. However, sometimes, like we discussed earlier, roles make sense. And luckily for us, OpenFGA can handle roles and more granular access control. So you only have to have one solution for them all. It's based on REBAC, or relationship-based access control, like we just learned about. And it's inspired by Google Zanzibar, which is Google's answer for the need for flexible authorization for its products like Google Drive, Google Cloud, and YouTube. Okay, so that was a lot of facts. You probably really only care about what FGA does. Like, what can FGA really do in real life? Well, I'm glad you asked. OpenFGA answers the question, is someone related to a particular entity with a specified relationship? Okay, so to begin modeling authorization with OpenFGA, you're going to have to do two things. First, we're going to have to define what's called an authorization model. And this is what an authorization model looks like. And we'll play with a little bit here coming up shortly. But what it does is you describe the entities that are relevant when you're making authorization decisions and relationships. So for example, in line 17, we specify that a user is a document viewer if it has been directly shared with them, if they created it, or if they can view a folder containing it. The next thing you'll have to do is define something called relationship tuples. Now, relationship tuples represent the system state and is defined by known facts of the system of who is related to what. So in this case, we have user Ann, who is a viewer, has a viewer relationship with folder X, and folder X has a parent relationship with document 1. OpenFGA uses the authorization model to follow the relationships between tuples to find out if there is a path from the user to the object. And if the answer is yes, it allows the request. Okay, so it's demo time, and I woke up this morning and prayed to the Norse gods that the demo works as planned. And I also prayed before I walked in here, so I think we're good. But I've got Yoda on my side as well. So let us go to the demo. Now, OpenFGA has SDKs that support all major programming languages, but as we all know, the SDKs just are a wrapper around these API calls. So for this particular demo, we're just going to hit the API. We're going to run through some scenarios using the API. Okay, now prepare yourself for another story. So imagine you're starting a new project at company TechDocs. And that new project, you need to manage access to TechDocs documents. The company has thousands of documents and hundreds of users, and each user needs different access to each of the documents, right? So we're going to need to figure out how to model that. First and foremost, we're going to need to start by creating a store. To create a store in OpenFGA, will hit the store's API endpoint. And we just need to set a name for our store. We're going to call it TechDocs Store. Actually, I think I have this one already, so we'll call it TechDocs Store 1. Boom. Okay, so when that store is created, now notice in the body, can everybody see? Yes, okay, good. In the body, we only specify the name. When that store is created, we are returning an ID, the name, and our created at, metadata. To make this demo a lot easier for us, we're going to create a variable from this because we're going to need to use this in all of our future calls. Okay, so why do we need to create a store? Think of it as a database, but specifically a database for access control. Now, by creating a store, we're telling OpenFGA where we're going to keep all the details of our entities and our relationships. So in this case, our users, documents, and the relationships between the two. Okay, so the next step, now that our store is created, we're going to create an authorization model in our document management system, because we need to specify which resources exist and how our users are going to interact with them. So we're going to hit the authorization models API endpoint, and we're going to define a schema. So in our schema, we're going to have type definitions. Our types are going to be user and document. And then our relations for documents are going to be viewer, editor, and owner. And we also need to have our metadata defined as well. Essentially, it's going to be the same thing as our definitions and our relations. So we're going to run this, and we will get back a authorization model ID. Okay, so let's go over what an authorization model is again. So an authorization model is essentially a blueprint, right? It describes the relationships in our system. For example, if a user needs to be, or a user can be an editor of a document, or they can be a viewer or an owner. So whatever relationships are going to exist in our system, they need to be defined in this authorization model schema. If they aren't defined in the schema, then they don't exist. Okay, so the next step, so we're copying and pasting this authorization model ID because we're going to need it for our subsequent calls. In our next step, we're going to assign relationships between specific users and documents. So let's say we have a user named Alice. Oops, hold on. Okay, so let's say we have a user named Alice, and we want her to be able to view document 1, 2, 3. Simple enough. Well, what we'll do in this situation is we'll hit the write API, and we'll make sure that our action is writes, and we'll fill in our tuple keys. So our user is going to be Alice, our relationship in this scenario is viewer, and our object, we're going to call it document 1, 2, 3. Now, I am going to update our authorization model ID. And let's run it. Okay, we got 200 okay and an empty object, which is fine. Now, well, let's talk about what a relationship tuple is first. It's a connection between the user and a resource. So it's defining the actual relationship, right? The tuple links a user to a specific resource and tells OpenFGA what the user is allowed to do with the resource. Pretty simple and straightforward. So next step, we're going to check to see if Alice can actually view document 123, right? Because, I mean, sure, we got a 200 okay, but let's just check our work. Okay, so in this scenario, we are going to hit the check API endpoint, and we are going to define our authorization model ID and our tuple keys. So our user is Alice, relation viewer, and we're checking for document 123. Let's send it. All right, so what we got back from the API is that Alice is allowed to view document 123. So what we did worked. So, I mean, this might sound obvious, but why are we checking permissions, right? Well, simple, to ensure that our system is working as we intend. Think of it as validating users' right to access before they access. So, let's see. Let's just say we want to check if multiple users can access the same document. For example, we have Alice and Bob. We want to check if both of them can view document 123. We would do that by hitting the batch check API endpoint, setting our authorization model ID, and defining our tuple keys. So in this particular scenario, we've got the object on both keys is document 123, relation is viewer, and our users are Alice and Bob. Now let's see what happens when we run it. Okay, so what we get back, what we get back is Alice is allowed to view and Bob is not. But let me share a little bit more about the correlation IDs. So we set correlation IDs, it's a string. In your application, it'll be like a GUID or something, a little bit more complex, but for simplicity's sake, I just made it 1 and 2. Because you notice when the API returns, or the API return is not showing us the actual users, it's showing us the correlation ID. So that comes from what we set in our body in our API call. So we didn't set up Bob's relationship tuple, but if we had, as a matter of fact, we can go back and do that, then we would get true. So let's go back and set up Bob, because why not? So user Bob, and we keep the same authorization ID and everything else looks the same. Go back to our right API endpoint and we're going to send it. Okay, we got a 200 okay. Now let's perform this batch check again, and we should expect to get allowed true for both. All other things are the same. Great. Okay, so why are batch checks useful? Batch checks allow for you to query multiple permissions at once. Now, let's say we wanted to, say Alice had viewer and editor permissions, or a viewer and editor relationship. We could also query both of those relationships in this batch query. It doesn't have to be for multiple different users. But, you know, in a system with multiple users and multiple resources, it makes it easier to do a batch check versus checking each individual document. All right. So let's move on to our next step. Let's say you want to check all documents that Alice has access to. But more specifically, we want to know which documents Alice has viewer relationship with. And this pretty common scenario, we can use the list objects API to do just that. Check to see exactly which objects that Alice has viewer relationship with. Now, this is a pretty common thing that happens for larger systems with hundreds or thousands of documents. You don't want to perform a check on every document to see what a user has access to. So let's see what the API, what OpenFGA provides for us in this scenario. All right, we're going to set our authorization model ID, if it will allow me to do that, which it is. Boom. So for type, we're going to define document. We're not defining the document ID. We're looking for all documents. Relation is viewer, and we're looking for our user, Alice. And what is returned back is document 123, which is what we expected. Now, if there were 100 objects in this, or if Alice had a viewer relationship with 100 objects, we would have a longer list. But it would just be simple like that. And it would be easy to display. Okay, so listing objects in this context allows us to find all documents that Alice can view, right? Without manually checking each document's access control. And it makes it very easy to query the relationships between the user and multiple resources. All right, so let's explore the list users endpoint. Now, let's say TechDocs Inc. has a policy where only certain users have permission to view certain sensitive documents, which is also a pretty common use case. For document 123, we have several users who are assigned the viewer relationship. And we need to list all of those users. The list users API helps us do that pretty efficiently. So what we do here is we're going to set our authorization model ID. We have our object of type document. We do have to set our ID here because we're looking for a specific document. Our relation is going to be viewer, and our user filters, we're just using the type and not an ID. So let's run this and see what we get back. All right, so what we get return is our two objects. We've got our user Alice and user Bob. So Bob and Alice have access to document 123. Let's talk about why we might want to do something like that. It allows us to efficiently return a list of all users that might have a certain relationship tuple, and it is great for querying relationships between users and objects, and it helps you see who has access to your system pretty simply and efficiently. Okay, so let's talk about updating relationship tuples. So we don't really update relationship tuples in an OpenFGA. We simply create or we delete. So let's say Alice is promoted, and as a part of her promotion, she needs to be an editor of document 123, right? What we would do in this case is simply add that relationship tuple. So we'll hit the right API endpoint, and we will make sure that the action is right and set our tuple keys. So Alice relation is editor and our object document 123. And let me update our authorization ID. Okay, so we've done that. So let's go make sure that Alice is an editor by performing a check. Oops. All right, so it worked. We have successfully made Alice an editor of document 123. Okay, so what if, for whatever reason, we need to revoke access? Say Alice no longer is needed to be an editor of document 123, and we need to remove that access and remove that relationship. Well, adding or deleting a relationship tuple is just as easy as adding one. And we'll still hit the right endpoint, but instead of writes, we're going to use deletes, and we'll set our tuple keys. And we'll also define our authorization model ID. And that's deleted. Now, if you don't believe me, we'll perform a check. So we can run this same check because we already have it set up, and we see that the API returned allow false. So now that we've created our store and set up relationships for users and documents, let's see what we can see from the current state of our store. For example, if we want to read all of the tuples that are available in our store, we can do that pretty easily too with the read API. Now, with this call, we don't need to put anything in the body. We just simply hit the read API, and we'll be able to, it'll pass us back all of the tuples that exist in our store. Pretty simple. One thing to call out, you'll see something called condition. This is if there were conditions, which would be like if you want to add a little bit of attribute-based access control or ABAC in there. say you want to have a condition that, say the document can only be accessed between the hours of 9 and 5, or, by a certain IP address, then that's where conditions would be. And you'll see something called a continuation token here. And continuation token is simply, if you have a long list of tuples, then it's like for pagination. So it's able to easily paginate these results using the continuation token. Now, let me show you, so this is the API, but another thing that's pretty interesting is the ability to query OpenFGA in the UI using something called tuple queries. And in this scenario, you can use it like using plain English. So let's say, here's a good one. It's actually got it. Let's see. Is user Alice related to document 123 as editor? Now we know we revoked that application, that relationship. So, but let's run it just to see what happens. No, she is not. So let's ask then if she is related to document 123 as a viewer. Ta-da! She is. So this depiction is to really show how flexible OpenFGA is now. In general, we are going to make these calls programmatically, but if you want to be able to interact with your FGA instance in the UI, it's available to you. Okay. So, it worked out. Okay, let's go all the way back to our code from earlier, where we made that API call to get the document in our document sharing code snippet. As you can see, we've integrated OpenFGA and we've pulled it into our project. And now, notice the difference in the calls in the get document method. Instead of doing the checks that we had earlier, all we have to do is simply call the check API that we talked about just a minute ago and see if the user has a viewer relationship with the document. And if the user is allowed, then we return the document. And if not, we return a 403 forbidden. Simple and easy. So, to recap, I know this is a lot of information in a short period of time, but let's kind of go over what we learned. We've learned the difference between auth in and auth z, and we had a scenario that made sense. We went over different access control models, and you all are graduates of Access Control 101. Congratulations, you can pick up your diplomas on the way out. And we talked through OpenFGA and the problems that it solves, and we even saw it in action. Now, I have a challenge for you. The challenge, should you choose to accept it, would be number one, to start the GitHub repo, because it's an open source project and GitHub stars are the bread and butter, right? If you choose, and if you're interested in learning more about OpenFGA, feel free to join the CNCF Slack. I would highly encourage it. And you can learn all things that are coming up about FGA. And you can try the FGA playground out for yourself. And that's it for me. Thank you very much, and thank you so much for joining my talk.